The students are crazily building their aircraft that they've designed over the course of the year. In 2 weeks' time they'll be flying them, so they're deep within the build phase now, and largely today they've been building wings, putting together electronics in order to make their aircraft.
Right, so I'm soldering the wires to the connection that goes to the battery. This is ESC, this electronic speed controller, and generally the project is going okay. We've finished manufacturing the wings today, we're just wrapping them now. Now all we have to do is manufacture the tail, finish the landing gear, and hopefully we're ready to fly on Friday.
So me and Sam here are running the avionics for our team. It's basically all the electronics inside the drone that allowed it to fly with sustained flight. So there's everything from the motor to the flight controller to back to the ground station, which is our laptop. Today we're trying to get the telemetry unit working. That's what's communicating between the drone and the ground station. We're having some issues with it, but we're making progress.
I'm on the electronics, so I have to make everything work in terms of the motor and the servos and the signals, making sure everything works.
Our team's been split into two, so we've got motor mounting and servo mounting going on one side, and this is taping the wings for streamlining and obviously making it look good as well.
The initial plan was a bit different, but while we were making it, we realized we needed some extra holes, we needed some more space for the electronics inside. So as we were manufacturing them, the ideas were developing, and it's good how all 6 of us come together. Everyone's got different ideas, and as the project progresses, we kind of develop new things and just make it better.
I think everyone's got a chance at flying this year. I think everyone's tried really hard, and yeah, fingers crossed we get some up in the air.
I'm excited for the flying day. Fingers crossed it will fly, hopefully, but I'm not sure.
And hopefully in 2 weeks' time, and another beautiful sunny day, we'll be flying them and seeing how they perform.
So our plane is McDonald's themed and it's basically been designed over the course of the past year using all the skills that we've learned through years 1 to 3. We came together as a team from avionics, from aeromechanics, materials, and we were able to come together and build a fully functioning and flying UAV.
It's been good. There's been some very interesting aircraft, a few that needed a little bit more work perhaps, but for the majority we got half a dozen or so in the air. 1 and 2 of them flew very, very well indeed.
We've just taken this out for a fly and it performed pretty well. We got a couple of loop-the-loops out of it and a nice clean takeoff and landing. So yeah, pretty chuffed in the end.
Comparing to some of the other designs, we were a bit worried at first, but after a bit of trouble with the landing gear down here, it finally got going, and yeah, it took off really well, really stable. At one point, the pilot had his hands off the controllers, and they were still flying perfectly well. So yeah, really happy with it actually.
1 or 2 of them today felt like commercial models that you could go and buy from a shop, whereas some of them are very unusual, but they still feel nice to fly. 1 of them did fly quite nicely, but there was a little bit of an elevator issue, and midway through the flight it just decided to stall, at which point it's straight down to the ground and out. It's a shame, because it had potential, really good.
Well, one of the things we've noticed is that the calculations all assume that we've manufactured these things correctly, and the manufacturing is where a lot of the error is induced. You know, we kind of assumed we'd get this beautiful airfoil out of the wing. Nowhere near that. We kind of assumed we'd get all the tolerances perfectly right. Because we're just students, we didn't manage to do that. But it'll be interesting to see how much it can actually do.
It's been really nice. Good weather as well, and it's good fun watching everyone else's planes fly around. So yeah, it's been a really enjoyable day out.
Seeing it actually go into the air and seeing all that work pay off is a great feeling. But overall, no, really great day, really great course, enjoying it.
I think the students have had a great camaraderie, because when they've come out, they've all been watching each other fly, and when the teams come out onto the flight line, you can see they're very nervous, because obviously they've been watched by their classmates, but as fail or succeed, they get a great round of applause either way, so there's obviously a really nice atmosphere from them.
Thanks to the Reese Foundation specifically and the iForge. Without the iForge, we definitely wouldn't have gotten it built this quickly. But also everyone within the IPO and in the university. It is one of the best projects to do at the university, I think, and it's it's great to have such an applied a project again, just to work on that's very far outside of the theoretical stuff that we usually do.
Today I'm here as part of the Industrial Advisory Board, and I'm here assessing the students, what they've done in the final year project and how they're getting on.
So yeah, really good today. Obviously you get some a mixed level, but the good ones were really good.
The caliber and the quality of students, the quality of the work is really, really good. And not only I had the opportunity to get a presentation, but then I probed them, I asked questions, just like we would in the industry. And the quality of answers that we're receiving is very, very good.
The standard keeps going up, and that's testament to the university and the facilities that they've got over the years. If they've developed that, it's helped them develop their students as well.
There are some interesting designs actually. Obviously these guys are making the UAV systems, and there are some interesting designs that have been debated in various aviation blogs. So there's a lot of the stuff that these guys are doing is very relevant to the industry.
The whole point of the project is to allow the students to learn in a real situation. So by getting some industrial feedback from us, it may feel a bit harsh at the time because we're quizzing them. We're asking them questions that they're going to get asked at interviews. We're asking them questions that they're going to get asked by their future managers. So really it's the first step to really preparing them to be interview ready and to be industry ready as well.
You've got manufacturing, you've got systems engineering, you've got electronic specialists, you've got aerodynamicists. This is as close to industry as you will get, and this simulates a very real design life cycle that you will see in industry, which may take a little longer in the industry, but this is a very real engineering life cycle.